we're going to be investigating sending non-binary data into the printer and then looking at how we get out of the printer to put into the label. So, we have our printer, and we know that we can send data into the printer via the RS232. We know that we can send data in via Ethernet, and we also know from previous lectures that we can send it in binary data via the clock signal. So today we're going to cover the top two, and we're going to look at getting this data into what we call the data streaming buffer, and then taking it from the buffer and getting it into a label to print, and how we can do that. There's just one little word here before we start, and that is that in CodeNet, which is one of the protocols we use, there is a command, the OE command, which sends data in to this buffer. But it's not a pure straight-through command, because you have to go to CodeNet and then step into the buffer from there. So you're going over a couple of hops. So this command is only really used by customers who have a very small PLC with just an RS232 port on it, and that's all they can use. We don't normally use that command for data streaming. Right. So inside the printer we have a buffer. It's a piece of memory. This piece of memory can be divided up to accept data in many, many ways. So first, before you start to use it, you need to set it up to receive the data. This is just one long piece of memory, so normally we would say we want this thing to accept, for instance, 4 items of data. And then we take each item and we say, well, this item of data, we want it to, for instance, start with an STX, and we want it to end with an ETX, and we'll put the data in here, A, B, C. So we need to format it, this bit of memory, to say it's going to arrive with an O2 at front and an O3 at the end. We don't have to have those on there, but personally I use them because if I have a string of data coming into the printer and I'm trying to find what's going wrong, because something's going wrong, this is like brackets around my data. And having the brackets around, I can see where the data is quite easily. But you don't have to have them like that. For instance, you might have a check wire, and onto the check wire is connected to the printer, and onto the check wire you have something like a fire extinguisher arrives. It sits on here and the data is pumped out into here. This data might look something in ASCII terms like ABC 1, 2, 5, X, Y, Z. This being the weight which we want to print on there. So we can take that data and we can set this up to mask it so we only see the 12.5. It's another way of doing it. We can also say that we want to jump so many characters in and read the next 3 and then forget the rest of it. There are many, many ways to set this up. Once we put the data into our buffer, I'm writing it this way around because my buffer is, it's like a pipe and my buffer is going that way. I'm filling it from the outside here, and so I visualize it in my head, and I'm taking it from here to go into the label. So inside our label, which we put in, we need to put an updatable field. Now you can have many of these updatable fields in there, and each updatable field will extract data from this set of data. So if I want this field to just extract the first 2 items, I have to set this field up to just extract 1 and 2 from the data that's sitting there in that buffer. I could have another field in here which extracts just the 3. or I could have a field there that extracts all of the data. It depends on what the circumstances are that the customer wants us to do as to how we get the data out. You can only take the data out of one of these items for one label. Once the print go happens, we can get rid of the data. Saying that, we can also have batch printing. In batch printing, we normally set the buffer to one item in there. We send the data in here, and then every label that's printed for that batch gets exactly the same data in. When we change the batch, we can then change, and the data printed will be different. So that's what we normally use for batch printing. Now, if we're going to be sending in from RS232 or from Ethernet, remember both of these are serial. This one generally people call a serial, but it's not. It's a recommended standard 232, and this is Ethernet. With RS232 we have a baud rate. For instance, if your baud rate is 9600, this means that we can tell the speed with which each byte, that's a byte, we can tell the speed with which each byte is going to leave the controller and arrive at the printer. So it's deterministic. It's always going to be like that. Nothing else is going to get in the way when it's on the wire. Ethernet works in putting data into packets. Packets should be a particular size, and they should go down to the buffer in a particular way. Doesn't always work like that. Sometimes Ethernet will divide the data you've sent, and it might just be a small bit of data for some reason that it did this, and the 1, 2 is in one packet and the 3 is in another packet. Or in this case that we've got up there, the 4 is in. So we've got 2 packets of data going down to the printer. It may be the case that the 4 arrives at the printer because of our network trafficking that's going on here, traffic. The 4 will arrive before the 1 and the 2. Then it has to be reassembled inside the printer to go into the buffer. All of this takes time. This is running at a higher speed than what this is going to run, but this takes time to get it reassembled to go into the buffer and to come down here. So generally in industry we still use RS232 because of this deterministic quality. We tend not to use Ethernet, especially in a noisy environment, because you get bad packets, especially not on wireless networks in factories. There's just too many bad packets and it slows it down. So we tend to just use RS232, and we use it either at 9600 or 19200, although you can go up all the way up to 115200. Of course, we know the faster we go, the shorter is the length of cable we have to use, and the more we have to shield the cables. So the choices that you would have as a customer would be RS232 or Ethernet, and you generally choose RS232. We have a buffer in the printer which we need to first say how we're going to use it, how it's going to be divided up. We need to have a label, we need to put the updated text fields in the label, and then we're ready to go. When we send the data down via either of these methods, we generally, just write this out here, put our buffer back, we generally have some markers in here that can help us to keep the level of data in here so that we never run dry. So we can have, they call them the water line, the high water line, and we can have a low water line. So there's 2 of these we can have. We can set them to come out at different points. So that will send out to us that we've reached this particular point, and we'll then know to fill it up. When we're sending data in, we can also say, instead of just replying to me with a yes or a no, an ACK or an ACK, reply to me with the number that that item has gone into. So I then know if I've got 10 in there and I send the 11th item in, it comes back with 11. If I haven't printed any, I've got 11. If I've printed one, I know I'm down to 10 again, and so on. There is several items like this which we use to keep control of how much is in here. We can also ask it, so we poll. We poll it every few minutes, depending on how fast we're printing and how big the buffer is, and we'll say, tell me how much data you have in. So we can ask it for the data, we can watch the water lines, and we can get it to tell us the number that the data is that's gone in. With all of these things, we're trying to keep this full of data to the point where we want it to be full of data so that we can print these labels. The faster that we print labels, generally the smaller your set of data is. That stands to reason, because if you're printing a label that's 1 meter long, you won't be printing that very fast. But if you're printing very small labels with just say 2 or 3 items of data, we can print that very fast. This data can also go inside updatable text fields on things like data matrix and QR, quick response codes. So inside those you can have updatable text fields, and each one of those can change. A lot of people will also want to do things like print lucky numbers. These are the promotional codes that you get on things. You text it in and you win a prize, or not. Now, when you do those, if your top prize is a Ferrari, you only want to have one top prize, a Ferrari. So once we've used this data, we can delete the data. So earlier on I talked about batch printing, where we say the data stays there until we remove it. You can have more security type printing where the data is there and it's gone. You can have also security printing where you have just one item, and the last item in is the item you print, so it overwrites the buffer. So there's one item in there, and the last item that went in is the item that gets printed, so you can overwrite it. So there are different methods of setting up the buffering so that we can get the print. We've got different methods here of getting out how much is in there and keeping control, and as you saw earlier, we also have different methods of sending the data in. Any questions?
The first diagram you drawn, you mentioned RS232 Ethernet, and it's a binary one.
Binary.
Can you explain on the binary where that's coming?
Binary is the data that needs the clock signal to come in with. So inside our printer we have the shift register, we call it. And the shift register is a piece of electronics inside the FPGA. And we send the data down, and the data comes in as ones and noughts. But to tell it how fast it is and to get it into this shift register, we have to send with it a clock signal. And the clock signal will clock each of these in, and it'll start here with the 1, then it moves the 1 down there as a 0, then it moves 1, 0, 1. As you can see, it clocks it all the way in. Once it's all in there, then that's ready. It's copied out of there into a software buffer where we can then use it, and it's copied down into your labels. We pull it out and put it in the labels, not with updatable text fields, but we have to use something called Lua scripts. So we have to write these Lua scripts to extract the data. Lua scripts will grab the whole of the buffer, the binary data here, and it will shift it left, right till it finds the data at once, and then it will take that data and convert it into a character to print. A lot more can go on inside the Lua scripts, because you can have lookup tables to look up the character, to change it to something else, and so on. So it can get very complicated, very complex. That's a quick analysis of that.
So what is the percentage of customer out there that uses this type of setup in the production line?
For this one or the other?
Or the others?
It's generally people like for instance, all the eggs, where if you were needed to put data into an egg that was particular to that farmer only, or if you were on a production line where you needed a specific thing like a weight on it. In the whole of our printers, you're probably looking at, of customers, a small percentage, but of the number of printers sold to those small percentage of customers is large. They are generally the bigger customers. So they might be buying off of us 100 printers a year, maybe they're 15% of our market. But in volume terms and the amount of printers and ink and spares we sell, it's big. Okay. We're happy with that?
Any other questions? Right,
Right.
Stephen. Could you